In this video, we are going to dive deep into Riverpod. We will learn about all the essential components of Riverpod, limitations we get while using it, and solutions to them. One of the solutions I've covered is the next big thing in the Riverpod world. So make sure to watch the video till the end to know more about it. Let's start the video by understanding why we need Riverpod in the first place. There are some problems with Provider which cannot be fixed. Some of those problems include confusing and tedious syntax from proxy provider, multiple providers not having the same return data type, and the infamous provider not found exception. To counter these problems, Riverpod was written. However, Riverpod is not just a state management solution anymore. It is also a replacement for many design patterns like singletons, dependency injections, and service locators. It also helps in fetching, caching, and cancelling network requests while also handling the error cases. To get started, head to pubspec.yaml file and make sure you have the latest version of Flutter Riverpod installed. Riverpod is divided into 3 packages: Hooks Riverpod, Flutter Riverpod, and Riverpod. Hooks Riverpod is used with Flutter hooks, Flutter Riverpod with the Flutter SDK, and the Riverpod with Dart programs. That means you can create CLIs using Riverpod. After having that in place, go to the main.dart file, wrap your root widget, the widget that's passed in the run app, with a widget known as ProviderScope. This ProviderScope widget is a constant and it comes from Flutter Riverpod package. This ProviderScope keeps track of all the providers and ensures that there's no leakage of state in spite of the providers being declared globally. Global declaration of providers or variables in general means if suppose I have a variable like string name and I've declared it outside of any function and outside of any class, I've declared it globally. Usually, global declaration, be it of variables or providers, should be a problem because of mutability issues. Meaning, if a non-constant variable like this name is declared, its value can be changed by any function. For example, if I have the main function right here, I can change the value of name over here, right? So I can type my name as Rivan over here. And I can do the same thing in home screen. Here I can just import main.dart file and set it to nummon. Imagine this for hundreds and thousands of files. Do you think it's a good practice to do this? It's not, because it would be very difficult to know which function changed the value of name and if we ever want it or not, and to find it will be a big task and we generally don't want to do that. So you might think, if this is prohibited, why does Provider or Riverpod even do this? The reason for that is the providers declared globally in Riverpod are immutable, and this is for all the providers in Riverpod. They all are immutable except one, which we will talk about in a while. Anyways, now let's just remove this line and get to the first type of provider, which is provider itself. Riverpod has multiple providers which can give us access to state, whatever state we want to access, and for them, each provider has its own purpose. So the very first type of provider is provider. It is called provider. If you're coming from provider package, you already know about it. As the name suggests, it is an object that provides data to widgets or other providers. It is a read-only widget and cannot update the value inside of it. It can be used to provide primitive, non-primitive data types and even instances of classes. To create a provider, what we do, and this follows for all the type of providers, not just for provider, we put a final because the value cannot be changed. And then we give the name of the type of the provider. So I'm just going to provide name provider. And I always like to suffix it with the provider, because suppose if I have this class right here and I've named this provider as name, and here I'm using an instance variable of the data type string. So I have string name over here. I'll get pretty confused, right? If I want to access this name provider or the name variable that I've created over here. That's why I like to suffix it with provider so that there's a clear distinction. Then is equal to and then the type of the provider. The very first type of a provider is provider itself. So we have provider, and here we will just create a function. But you can see it gives us an error. The reason for that is this function gives us access to something known as ref, which is ProviderRef. This ProviderRef will allow us to talk with other providers. We'll take an example for that later on, but for now, all you need to know is that ProviderRef will allow us to talk with other providers. Now if you hover over this, you can see it is of the type provider null. But that's not what I want. I don't want to return null. If you don't pass anything, what this is doing is basically returning null like this. And that's why the data type over here is null. However, I want to return the name. So I'm just going to have Rivan returned over here. And now if you hover over this, it's of the type string. It automatically detects the type that you are returning. However, if you want, you can just add a data type over here. So you can just write string over here. And that works too. But if you pass an int over here and return a string, it will throw an error for you. So you have to change it either over here or just convert it back to string. If you have int, you'll return 2 like this. And a shorter syntax to return from this is, since this is a function, we'll just create an arrow function. So we'll just have something like this done. Since this is a function, we have an arrow function right here. But since I'm returning a name, I'm just going to create something like this now. Now what I want to do is whatever name I've returned over here, I want to display it in this screen. So it's in a separate file itself. I don't have the name property over here. I don't have access to name provider over here. I have access to it in a different file. So how am I going to do that? Well, for that we have the reading properties. There are two ways to read a provider in any file. So since this provider is globally declared, you can read it in any file that you want and it will work for you. So if you want to read it in the home screen, there are two ways of doing it. First one is using a consumer widget over here. This consumer widget is given by the Flutter Riverpod package. So you just need to remove the stateless part and add consumer. So you have consumer widget. And then here you can see we are getting the error. To fix it, just put in a comma and have WidgetRef. This WidgetRef is similar to the ProviderRef that we had over here. Only difference between these two is WidgetRef allows you to communicate from widgets to other providers. That's what we are going to do. We are going to make use of this ref so that we can call the provider because we are in a widget, right? So from this widget, we are going to contact this provider. However, this ref will allow you to communicate from one provider to other provider, obviously. So that is the difference between WidgetRef and ProviderRef. Now to display the value, what can you do? Well, you can have final name is equal to. Now you just want to extract the data given from this provider. How will you do that? Well, again, there are multiple methods for this. I'm going to show you the three methods. First one is ref.watch. You want to pass in the name of the provider. Our provider is name provider. So we have that. So what we are doing is watching the name provider and you have access to name and you can see it infers it that it's of the type string. We have nowhere mentioned it is string. But since our provider has already decided that this is of the type string, it knows, yeah, whatever provider we are listening is of the type string, which is pretty cool. We always need to have data types for our variables. Now we can just take this name property and have it over here. Also remove the constant because we are watching it from a provider. Now we can restart the entire application and here you can see Rivan Ranawat shows up. If you change the value here, for example something like this doesn't get updated because changes on hot reload, example when we just click Ctrl S in provider is not supported in Flutter Riverpod package. So you just need to restart the entire app and after you do that, you get access to Rivan. Now, what is the other type of reading method? As I said, there are two types of reading. One is a consumer widget, other is not using a consumer widget and instead having a stateless widget right here and then you don't have access to WidgetRef anymore. You'll also remove this ref and here in the column, you're going to wrap it with a builder method or a builder widget and then you're going to change it to consumer. Now the builder will give access to context, ref and child. I'll explain it to you. What is this consumer? Well, we wrapped our entire widget with the consumer widget first. Now we have access to a widget where we can only listen to a certain part. For example, if we add something like our name again over here. So we have ref.watch name provider, and we are storing it to name, what we have already done before. But now we have access to context, ref and child. Context we know is build context, child we already know, but ref is again WidgetRef. So we have the exact same thing that we had earlier, but instead of changing this from a stateless to consumer widget, you need to wrap the widget tree with consumer. So if you restart the app and see, it's the exact same thing. Everything is the same. So now you'll think, what is the difference between consumer and consumer widget, right? I mean, both are the same thing, aren't they? Well, the basic difference between both of them is consumer widget. In consumer widget, when we had our provider something like this over here, which WidgetRef over here, the entire widget would rebuild when there was a change in the variable. So suppose the value of name changed. Of course, it's not possible with provider, but if the name value changed over here with some other type of provider that we are going to look at, and things would get much more clearer then the entire widget will rebuild. Now you can see we had an app bar and it didn't depend on this name text. So even if the name changed, the scaffold would rerun. That means the app bar would get rebuilt, and the body dependent on the name of the user would also rebuild. But in a likely scenario, we just want this center widget to rerun, not the entire scaffold, That's why we have used consumer instead of consumer widget. However, if our app bar also wants the title, and the title should be the name of the user, in that scenario, we can't use consumer. I mean, of course you can wrap this with the consumer method just like we did earlier, right? So you can just remove this line from here. You'll have it right here, and then you'll have context, ref and child. So you have it. You can wrap the scaffold with consumer, but what's the point of just nesting things up? It's not a great situation. We should always prefer not nesting much, It creates a lot of confusion, especially when the widget tree grows. So that's why, to avoid it, we have the consumer widget. So with this, we get access to WidgetRef over here. And now when we want, we can return this remove this consumer, and then we have access to name. And now whenever the name changes, the scaffold will rerun. And this is a likely scenario because the app bar also depends on name, and even this widget. However, if this does not depend, and there are other widgets that do not depend, you do not want to rebuild them. So if you have something like a bottom navigation bar as well, you don't want it to rerun or rebuild. So try and divide your application or your widget tree into smaller parts, so that whenever necessary, you can directly use consumer widget, and if not, you don't have to use consumer, right? Great. Now after having that simplified, you can see Revan and Revan shows up. And I also mentioned that we have different types of methods to read a variable from using ref, right? Once we have access to ref, we have different ways of reading it. First one is ref.watch. Second one is something like, let's just name it name read. So you have ref.read, and then you can call it name provider. So what is the difference between ref.watch and ref.read? Well, ref.read is a one-time thing only. So when you just want to read the name of the provider, so like we have this, so we want to read the value of the name provider just once, then we use ref.read. However, if you want to continuously keep listening so that you get to know if there are any changes or no changes, you can use watch. So generally, it's recommended not to use ref.read in build method. It should generally be used outside of the build method when you have a stateful widget. And it's generally recommended that you use watch inside of the build function and not outside of the build function. We're going to take a look into some example, and things will get much more clearer when we have other types of provider. You'll notice the differences and you'll notice when to use what. In our case, we just have a provider for now, so things might get confusing. You might also think, what's the purpose of watching a provider when it's only a read-only widget, right? We can't update the value of provider outside. So if we have name provider, we can't go and change it over here. Meaning if I want to change it, so example, we have name provider and I want to change it. Suppose I want to assign a value to it. I can't do it something like this, right? I just can't do this. You can see it gives us an error. Or generally this is done using the ref, because ref gives us access to these methods. So we have ref.watch name provider, and then if you try to set it equal to something else, it won't happen. It's just not possible for providers. So there are two important questions that you'll have. First one is, what if I have a stateful widget, right? So if this is a stateful widget and you call this, suppose my widget only, and then you want to have the same return scaffold part. There are some changes in this, that's why you've made it a stateful widget, but let's not discuss about it. But you have the exact same return data types from here. Your widgets are depending on name. How will you get access to WidgetRef over here? Well, obviously, of course, you can just wrap it with the consumer and get access to ref. Otherwise, instead of using ConsumerWidget that's mentioned over here, you'll have to pass in ConsumerStatefulWidget, a consumer state, and here we'll also extend the consumer state. Now you can see all of our errors are gone. Actually, we should be getting an error in the build method, right? Because here we had access to WidgetRef, and when we didn't put it, we were getting this error. Why are we not getting it here? The reason for that is WidgetRef is present in the consumer state itself. The reason for that is similar to context. If you want to use it in lifecycle methods like initState or dispose, you don't have to do anything. You directly get access to ref over here. You can see we have WidgetRef and it's coming from the consumer state. It's no longer a state, it's a consumer state. That's why we have access to ref. So now what you can have is very simple. Again, just final name, and to read it, of course, we are in the build method, so ref.watch, and then we'll just have name provider. It's generally recommended that you use ref.read inside of these lifecycle state methods, or inside of the functions that you create like this. So you have ref.read over here. Don't use ref.watch. It's not recommended, because watching creates a listener that will continuously listen to the changes built. But read will also create a listener, but it will just do a one-time listening part. It won't continuously track all the changes in your data inside of the provider. Alright, now let's just remove it. We have our simple stateless consumer widget. Let's have that. The second question that you might have is, how do I change the value if I want to? I said provider is a read-only widget. How can I make sure that I can change the value from an input over here? So for that, we have the second type of provider, which is StateProvider. StateProvider is to update the value from outside, which is not possible using the provider. It is like an upgrade over the normal provider. So how do we do that? Well, we have access to, let's say, name provider here. We'll just have StateProvider instead of provider. Again, we'll have ref. As I said, this is the convention for all of our providers that we'll create. And then the initial value. So our initial value is going to be Revan as well. Now you can remove this. I just kept it here so that you can compare the syntax. Of course, if you want, you can pass in a string over here. But now what I'm going to do is kind of different. Initially, I want the value to be returned as null. So here I want to define the value that's being returned as null. So what can I do? Well, in the StateProvider, you can see we have mentioned the return data type. If we don't, this also correctly identifies the type, which is null, but that's not what we are going to return. Initially, the name provider is null because the user hasn't typed anything, but later on, it will have a value. So here we are going to have a return data type of string with a question mark, which means it can have a string value or it can have a nullable value. So now in the home screen, all of this are in errors because this name now is of the return data type string with a question mark. And you can see we don't have to do any more changes. You can read all the providers inside of the build method using ref.watch. We have 6 different type of providers in Flutter Riverpod package. All have the same syntax to do and all use ConsumerWidget and WidgetRef to do so. So now what can I do here? Well, I'll have a text field over here which will ask the user for their input, and whenever they're submitted, I want to change the value. But before adding that logic, I'll just have a empty function. And here you can see name is of the return data type nullable. So I'm just going to have something like this done. This basically means that if the provider is null, we are going to have an empty string. And if it's not null, then we are going to have name provider. This is a shorthand syntax for is not equal to null, then we have name provider ref.watch name provider, otherwise this. But you can see it gives us a warning because there is a shorter method for this, which is this right here. Now if I restart, you'll see nothing shows up. The name is empty because it is null. The name value name provider is null, which means it will give us an empty string. But in the text field, what I'm going to do is update the value of the name provider because this is a state provider. So I'm just going to have ref. And how do we update the value? Well, we can use ref.read, and this is the key point to note. Ref.read is used in lifecycle methods if we are in a consumer stateful widget. It is used in functions that we create, and that's why we are having it right here because this is a function. If we want to extract it, we can have void on submit and we can extract it in a function outside. And if it's a function outside, what do? Well, we just use ref.read, right? I've already mentioned. But here we don't have access to ref. So we'll get access to ref from the parameter here. And then here we are just going to call the onSubmit function, pass in the ref, which is from the parameter here, and the value, which is from this parameter. And now since we are in a function outside, we can use ref.read. This is a main difference. Make sure to do so. If you don't, it will give you an error. Now after reading it, you can see it will again give us access to a variable. So we have final name is equal to this, and this is again a question mark. It hasn't updated. Of course, why will it update, right? We are just reading it, and reading is just a one-time getter. So now what can we do? Well, I want to update the value. So I'm just going to have ref.read, and there should be some method on it, right? Because it is immutable. Of course, all the providers, as I said, are immutable except the one provider that I'm going to take on in just a while. But this one is also immutable, so we can't have something like this done over here. So what can we do? It should have a method which will allow us to change its value. So do we have it? No, we don't, because this is of the type string and it's giving us string methods. So how can we get it? Inside the read method, we'll have .notifier, and this .notifier will allow us to change the value. So now when we do dot over here, you can see we have access to new methods. The string methods are now gone. Having .notifier here converts this to some new variable which we'll see over here. So now when you access to this, it's of the type state controller of string. It's not string anymore. But if you want access to state, you can just do like this. But there's no point of doing this because it's the exact same thing that we get after doing this. Anyways, so now that we have notifier here, we can get access to an update kind of method, right? So here we have it, update. And after having update, we get something known as state over here. This state is the previous state. That means the current state of our provider. And here we want to return what should be the updated value. So in our case, it's the state is empty as of now. And Here we need to return what do we need to update the value with. So our updated value is, let's say, going to be value. What is the value? Whatever value we get over here, which is whatever the user submits. So now if I restart the app and then just type Revan over here and then click on enter, you can see it changes both the places. So these were the two basic types of provider. Now there comes a third type of provider, which is an upgrade over the StateProvider. StateProvider is used for very simple values like a string that we had over here, an integer value, a double value, a boolean value. But what about complex values? For example, if we want to modify or manipulate the values inside of a class. What if I want to update a map? There will be many functions for that. For example, if we have a user model like this over here, it will have many of its functions, right? For now, we just have two properties in the user, but a general user will have many more properties in a real application. So we need to create a function for them so that we can change the name value. I'm not saying we can't do that with the StateProvider. It's definitely possible, but our logic will be lying around in our widgets. So we don't want to make our logic lie around in the widgets. As programmers, we want our logic to be together in a single place and most likely a class. So what can we do? Well, for that purpose, we have the combination of StateNotifier and StateNotifierProvider. What is this going to do? Well, let's look at an example to understand it better. So if we have a user here, let's just create a class called userNotifier. This is a model, right? This is the user model. And now this userNotifier will contain all the methods to update the name and the age of the user. So what can we do now? Well, we want it in collaboration with StateNotifier. So we'll extend this class with StateNotifier. This StateNotifier will give us access to state, a variable which can be used to update the data. And what is that data going to be? Well, whatever data type we pass in over here, the state will be of that type. In our case, it's going to be user, because we need to manipulate the values of the user model, right? We want to update the values of name and age. So we'll have extend StateNotifier and then we'll pass in user over here. Now you can see we are getting an error. The reason for that is we need to create a constructor which will call super.state. And now the error goes away. So what have we done? We have created a class that extends a StateNotifier and we have given it a return data type. This data type is going to decide the state of this user. You can see this is user now. But if I change it to a boolean value, this will become boolean. Simple. Now, after having this as user, I want to create simple functions that will allow me to change the name and the age of the user. So like as always, a very simple function for this will be void update name, and here we'll get access to something known as n, which is the updated name that the user has passed in the text field over here. And then we have n is equal to name. Name is equal to n. So what will we have? We'll have state, which is the user model, and this should be equal to, we need to update the value of this user class. So we'll have state dot name. And how exactly are we going to do that? Well, I don't know. It should be something like state.name is equal to n, but that's not possible because the properties of this user class are immutable. And actually, this entire class is immutable. So this is a constant user. Since this class is immutable, we can't change the values of this user class. Once assigned, we can't do that. So what can we do? Well, one solution would be to do state is equal to user, then we pass in the new name and the age will be state.age. And there we go. But this is a very lengthy approach, right? Because if we have more fields over here, for example, if we have age is like, if we have values like gender and all of the user properties, phone number and all, email, UID, this will get pretty big. And doing this for almost every function, every property will be very difficult. For example, we'll have update age. Doing the same thing for it will be very difficult. So what can we do? Well, if you just click on this bulb icon, and if you have .data class generator VS Code extension, you'll get access to this, with which you can generate a data class. It will give you methods like copyWith, which is very useful for us and much needed, a from map to map function, and to JSON from JSON, which we are going to use just after some time when we get to something known as FutureProvider, a toString is equal to operator, and a hash code operator or override method. So after getting all of this, my point is now you can just do state is equal to state.copyWith, and name should be set to n. So what this is going to do is copy all of the same properties of state, but only change name variable to whatever is passed to this argument right here. And this will do some magic for us. Let me show it to you. Now I'll go to the main.dart file, and now instead of having StateProvider, I'm going to create final user provider, which is equal to StateNotifierProvider. Here we use StateNotifier, and to provide the StateNotifier, to expose this StateNotifier, we'll get access to ref over here, and then we can just provide the user notifier class. Make sure to return a user notifier class, because if you try to give some value like a string, it will give you an error, because this wants a return data type of a StateNotifier class. It doesn't want a string or any primitive data type or even non-primitive. It just wants a class that is inheriting from StateNotifier. So now we can just have user notifier, and you can see it asks us in the parameter to give the user value, because here we have asked for the state. So what should be the initial state is what it's asking. So we can pass the initial state, and if you look over here, it is asking for the data type of user. As I've already said, if you want to give it a boolean and come back over here, you can see it asks for boolean. It all depends on what you pass in over here, and it's very important what you pass in over here. So here, what is our initial state going to be? Well, a user model with the name empty and age 0. And then we can have a constant user. Now we can just go to the home screen. For the on submit, we can comment it out. And here, let's remove this line. What do we want? We want the user model, so we'll have final user equal to ref. We are in the build function, so we'll have ref.watch, and then it's said to have user provider. And if you hover over this, it is saying that the return data type is an object, but that's not quite what we want, because now if I try to do user.name, you can see the property name does not exist over here, and that's true because it doesn't know that it's of the type user. To fix it, you can do something like this. So we have as user. Now if you hover over this, this is of the type user. But I generally don't like this approach, because doing explicit conversion means doing it literally everywhere. And if again we have hundreds and thousands of classes and files, doing it everywhere doesn't make sense. So again, we'll go to the main.dart file, and here for our StateNotifierProvider, we'll give it a type. So our first data type is going to be user notifier, because that's the class that we are returning. So we'll have user notifier, and then we need to pass in a second data type, which is user. So first is the class that you're returning, and second is the state of that class. So our state of the class is user, so we'll just have user written over here. Now in the home screen, you can see it identifies user.name, and here we can have user.age.toString, because this is of the data type int. Now whenever the user submits, actually before doing anything else, let's restart. you'll see 0 and empty string over here. Now whenever the user submits a value in this text field, I want to update the thing. So I'm just going to remove everything out and I'm going to have ref, and again we are in a function, and whenever we call another function we generally use ref.read. You can see even here it gives us a tip: avoid calling read inside build if the value is used only for events. So if you have counter ref.read, it's said not to use it. However, in the onPressed, it says to use this line. Alright, now we want to read or update the value from user provider. And now if I have access to this, you can see again it's not giving me. We had seen it earlier, doing read gives us access to the user model, not any method that can change its value. And we saw to fix that, we called the .notifier method, and then we have access to new set of properties, because this is now of the type, earlier it was state controller, now it is user notifier, because this is state notifier. Earlier it was state controller when we had StateProvider, but now since we have StateNotifierProvider, doing .notifier gives us access to this entire class. So thus we have user notifier now. So if we have access to this entire class, that means we have access to the instance of this class, we can easily call this method, can't we? So we can just call .update name, and there we have it. But that's not it. We also have access to, and after that we can just pass in the value, which is what we get from the argument here. Now we can remove this user, no need of it, because update name doesn't really give any value. You can see this is of the type void. Now I can restart the entire app, and now if I try to change it, for example like this, you can see it changes. You might think what is the difference, but as I said, the difference is that we can create multiple functions and all of them will reside in just one single class. As developers, since we are in need of something robust that's easier to test, we generally use the StateNotifier and StateNotifierProvider. We don't use StateProvider because there are very less use cases of having to change a very simple value in bigger application. And all of our business logic now lies in just one class. So if you want to have another property now, which is void update age, here you will get access to integer. So this will be a, and then you'll have state is equal to state.copy with a. And then you have suppose another text field here, and you create another function also, which is on submit age, and you call update age, and then parse the value that's coming, assuming that the user is kind enough to just pass in a normal integer value like 10 or something. Even though it's a string, it can easily convert using int.parse. So now if I just restart and type in something like 10, the reason this happens is because I've not taken this function and put it right here. After doing this and restarting the app, now if I do something like 10, you can see the value updates over here, and when I do something like this, it updates over here. Perfect. And you can do it for as many properties as you have. It's a better way of doing it. One thing to note is whenever you update the value of state over here, only then will all the clients that are listening to it, for example this line right here, it's listening to this user provider, right? It's listening to the changes that are happening in the user provider. So only when the value of this state changes will this rerun. So if you do everything else, for example, if you try to manipulate the state like n is equal to an empty function, empty string, and then just try to do something like n is equal to doctor plus n and something like this, but you don't do state is equal to state.copy with name, and if you don't do this, nothing will get updated. So now let me show you a demo. If I restart the app and do something like this, you can see no update happened. You change the value of n, but you haven't changed the value of our simple name property. And that is not good. That's why make sure to change the value of state. Even if you do state.copy with, it will not run because you've not really given the state its value. So do this. Another thing is that the state over here is immutable. So if we take the state and try to use it or update the value over here, it's immutable. For example, something like here, we have .state. We can't assign it to another user model, right? It is immutable outside of this user notifier class. However, inside of this class, you can change the value of state. And third and the final thing about StateNotifier and StateNotifierProvider, what if you don't want to pass the value of the state from here? You directly want to define it over here in this class itself. In that case, you can remove it from the user notifier, go to the user notifier class, remove the super.state, and then you can have a colon, super, and then you can pass in the state. What is the state going to be? Well, exactly this function model, right? Name and age 0. So the difference over here is when we call super.state, we are basically telling that whatever we get the value from here, we are just going to take it in and notify our StateNotifier class because that's what it wants. It wants access to state. But now what have we done? We have removed the call from the constructor saying, yeah, I don't want to accept it from the constructor. That means I will not pass it over here. And instead, I'm going to have colon super, which means it will call the parent class or the inherited class. The inherited class in this case, or the class that we are inheriting from, is StateNotifier. So we just call the super method. That means we call the constructor of the StateNotifier class, this part right here. And you can see it wants access to state. And we are just passing in the state, which is the constant user with no name, an empty string, and 0. It will work just as same, but instead of taking it from the parameter here, we are doing it from here. Just a very simple thing and an explanation of what was happening when we use super.state and super over here. We are just telling our StateNotifier class and telling it about this initial state. And then of course we can change the later value of state how and whenever we want. Okay, now the last thing which I forgot to tell you is what if you want to run a constructor? That means you want to do something as soon as this user notifier class gets initiated or gets run. So you can just do something like this, and there we have it. You can just make your calls or whatever. So if you want to update the name as soon as something happens, you can just pass in AAA and do that. Now if you restart, our initial name should be A and age should be 0. And this is what happens. We have A and 0. So this is how you run a constructor. But anyways, I'm just going to have this right here. Having knowledge of StateNotifier, I want to give you knowledge about the third type of ref property that we had. I told you we can read from using ref from using 3 types. We have ref.read, we have ref.watch, and the third one is using the select method. So the syntax for this is having final user is equal to ref dot, let's call it user select. We are in the build function, so we'll have ref.watch. Then we are going to have user provider, and over here we have access to a method called select. And you can see it gives us a value which is of the type user, and we have something. You don't know what's going on, right? Well, to explain it pretty simply, this build function now reruns the entire widget tree whenever the value of this user changes. So if the value of name changes, it will rerun. If the value of age changes, it will rerun. What if you want to do something like this widget tree should only rerun when the value of name changes? How can we do that? So we want to rerun the entire widget tree when one property of this class changes. That's why we use the .select method, which is present on the user provider or any type of provider. So if you want, you can just use the select method over here also. So you have user provider.select, but we are doing it in the watch method so that we can watch the value for its continuous changes, right? So we want to read a property known as name. That means the entire widget tree will only rerun whenever the value of name changes. To give you a demo, I'll remove this user provider or this user class, and then I'm just going to have user. You can see this is now of the type string. So you will remove it from here, restart the entire app, and now whenever you change the value like this, you can see both the places it gets the same thing because it's of the type string, which means it's a name property. And if you change the value of age, nothing gets changed, even though we have the age property right here. So that's why we want to use the select property. We use it whenever we want to listen for changes in value of one single property from a class. You can do the same for age, and thus here over here you'll have to put toString, and when you restart you have 0 0. If I do something like this, nothing gets rebuilt, but if I change the value over here, it gets changed. You might think it's the same thing as having final user is equal to ref.watch user provider dot name, but it's not the same thing because you're watching the user provider. So whenever there is any change in the user class, be it age or name, this will rerun. To check it, you can just call the print function and have rebuilt over here, and you'll get to know this entire function rebuilds, because what we are doing is just accessing the user property and calling the name property on it. So basically we are listening to the user class and then accessing the name property on it. However, in this case, we are not watching the user class. We are watching user classes one value which is returned over here, which is age. I hope you get the difference. It's not the same thing. Anyways, I'm just going to remove everything and have a very simple user.age.name and user.age back again. Sweet. So now we have covered 3 types of providers. The next type of provider is the ChangeNotifier I'm not going to go deep into the ChangeNotifier If you want to know more about ChangeNotifier and ChangeNotifier I would recommend you to watch my Provider video, because this ChangeNotifier class directly comes from Riverpod to easily migrate from Provider to Riverpod, because many of the functions in Provider have ChangeNotifier class. That's why it's there for easy transition. But however, in the Riverpod documentation, it's mentioned that we shouldn't use much of ChangeNotifier if we are building our application from scratch. It's always recommended to use StateNotifier. So what is the syntax like? And I'll show you the difference, and I'll tell you why it is encouraged to not use ChangeNotifier. So we have class user notifier, and I'm just going to add change at the end, and then it is going to extend the ChangeNotifier, which is not from Riverpod, it's from Flutter SDK itself, the material.dart, and then we can create the similar functions. But in this case here, we don't have access to anything like a state or anything which our StateNotifier gives. Instead, we have to create that on our own. So we'll have user is equal to user and 0, and this will be a constant. Then we have to create the same functions. Then we can have user. Same thing, exactly same. Here we are treating user as the state variable. Here we have done the same thing, but instead of having to do or create user variable, state did that for us. Now we'll have to go to the main.dart file and of course create something like this. Here we use StateNotifier to expose StateNotifier. Here we are just going to have user ChangeNotifier is equal to ChangeNotifier. We have access to ref over here, and then we are going to return a class of ChangeNotifier. So if you try to return a string, it won't work, just like a StateNotifier. But if you also try to return user notifier, it won't work. What you need to return is user notifier change, and now it's done. Now similar to all of this, we are just going to have ref.read user ChangeNotifierProvider, user ChangeNotifierProvider, and here is the difference. Here we use .notifier so that we could call the functions, but in this case we don't have to do that. If we remove the .notifier, it still works. So if you do dot over here, we have access to all the methods. We don't have access to the user, right? So that would mean if we do user ChangeNotifierProvider here, this is of the type user notifier change because this is exactly like this. So we have access to the methods here, right? Like dot update age and all. We don't have access to the user model or the state, so to say. So we'll have to do dot user and then we'll get access to the user. And then we restart. We have this and nothing works because this is not like user notifier or a state notifier class. Instead, whenever you want to rebuild the entire UI, you have to call notifier listeners function. Once you call this function, it will notify all of the clients that are listening to it, for example ref.watch, and tell, hey, I've got a value, a new value, and it's been updated, please check. So it will rebuild. Now if I do something like this, you can see it updates. You might think it's the exact same thing, right? Now I just need to put notify listeners here and in every function and it will be the same thing. And you're right, there is no difference in the point of view from a user. But as a programmer, you'll see this is mutable. I said in the start, right? We have all the providers immutable, which is a good thing, but only one provider is mutable. Others, in the start, if you remember, I said we have all the providers immutable, but only one provider is mutable, and that provider is ChangeNotifierProvider. This is immutable. That means you can do something like this. So if you have like this, you can do this. That means we can change the value of the user object outside of the class. Unlike StateNotifierProvider, ChangeNotifierProvider allows that. And that's a very bad thing, to be honest. And that's why Riverpod also does not recommend doing this. However, if you have a provider used project and it's pretty big to convert, we have ChangeNotifierProvider and you can use that. It's not recommended and I would also recommend you to not do so. Now, after having a brief knowledge of ChangeNotifierProvider, the next type of provider is the FutureProvider. FutureProvider, as the name suggests, is a provider based on HTTP calls or asynchronous code, even Firebase calls. So when this FutureProvider is used for futures, so if you have asynchronous code, you'll definitely be using FutureProvider and it will make your life much more easier. It is kind of a replacement and a shorter code for Future Builder and a better one in my opinion. I'll show you why I say that and it will be a lot more interesting. Let's get into the world of FutureProvider. But first, let's just remove the ChangeNotifierProvider and even StateNotifierProvider. We don't need them anymore. I hope you've understood the differences between both of them. Also, I'll remove all of these functions, all of this, and we are back to what we had started with. Except still we have ConsumerWidget and we are going to keep using it. So now in the main.dart file, let's create our first type, our actually fifth type of provider, which is FutureProvider. So to give the example of a FutureProvider, I'm going to use an external API. Of course, you can use the future inbuilt class to display some values, but I think the best way to do it is to give a real life example, and that is from this API. JSON placeholder API, this will give us a random user, and when we go to this URL. So I'm just going to copy this URL, and also I've made some changes in the user model because this is the data we get. We want to get the name and the email of the user. That's why I've created this. Of course, if you want, you can add other fields, but I'm just going to go with 2 just for example. And then obviously the same thing, the future provider we need to create. So I'm just going to have final, and then I'm going to call this fetch user provider, and this will be equal to future provider, similar to all the other providers, and obviously this part right here. If you hover over this, this is of the type null, just like all the other providers. Now what I want to do is I want to get this API. So I have to use a plugin like HTTP, which I've already installed, or you can use DO and it should work for you as well. DO will give you additional features too that will be helpful while using FutureProvider, especially like cancelling the network request that you're sending in case the user just goes away from the screen, right? So anyways, what we want to do is send a GET request to the URL we've copied. So let's just put in the URI over here. Let's call this the URL. And now I want to send the HTTP GET request. So I'm just going to have import HTTP dot, and we are going to use it as HTTP. And then we are going to do HTTP.get and then URI.parse. I'm not going to go much into details for this GET request. I think you already know about it. But anyways, if you don't know, we are just sending a GET request so that we get the data back. So we are just going to have return http.get. You can see this is of the type FutureProvider response because GET request is having the data type of future response, and since we are in the FutureProvider, it will ignore this future and it will just return a response encapsulated in a FutureProvider. But that's not what I want to do, right? Once I do the GET request, I want to send the user model across. So I'm just going to go ahead and use .then, and whenever this HTTP request is done, we will get a value, and this value is a response. This is a short form for await. So if you want to do await, you'll have to add async. Instead of doing that, I'll just use .then. I'll get the response, and I just want to return user.from JSON, and whatever I get, I'm just assuming I'm going to get a successful part. I'm not catching the error here because error will be caught somewhere else in our UI file. That will be very interesting. So we're just going to have value.body passed in. Of course, if you want, you can go ahead and catch any error if you want over here, but there's no point of doing so because FutureProvider, as I said, is a replacement or a better version of Future Builder. Now we'll get to know why. If you just come over here, you can see FutureProvider is now of the type user because we are doing .then. So whenever http.get is done, we'll get the value, and we're just converting the value to a user model, and we're returning it from this entire function. So this is now of the type FutureProvider user. So here comes the question now. How do I display the user name or user email over here or in the app bar, whatever? For that, let's go to our home screen, and you might have known by now that we always use ref.watch, and we do it for all the providers that we have done till now. For provider, we did that, StateProvider, StateNotifierProvider, ChangeNotifier everything. But if you do ref.watch for a future provider, let's see what we get. So I'm just going to copy this, paste it in here, import it, and put it as user. And you'll see this is now of the type AsyncValue user. What is this AsyncValue, you might ask? AsyncValue is like a better version of AsyncSnapshot. What is AsyncSnapshot? Well, if you return something like a future builder, and of course you need to pass in some future, I'm not going to pass in anything. I'm just going to keep it as it is. But here is our AsyncSnapshot. This AsyncSnapshot gives us access to you can see snapshot.connectionState, snapshot.data, snapshot.error, and snapshot. So you can see we get all of these things, and the problem with async snapshot is that the snapshot.data, snapshot.error, they're not interconnected with each other. So just for doing what we want to do, of course, I'm not saying we can't do all of these tasks with Future Builder. Of course you can do it. I said it's a replacement. So if you just try to do something like that, you'll have to do if snapshot.connection_state is equal to connection_state.waiting, and after that you'll just return a loading bar, and then you'll check if snapshot.date has data. So if the snapshot has data, you're going to return your widget tree, which means all of this part. Otherwise there is no data, and you're going to return that yeah, we didn't get any data. And then you're also going to have snapshot.has error. So if it has error, then you're going to display the error. If it doesn't, so async snapshot basically suggests that all of these states are not interlinked with each other. They're independent of each other, but actually data, error, and loading are pretty interconnected to each other, aren't they? So it's not a clean way of doing it, in my opinion. So AsyncValue is a better thing, in my opinion. AsyncValue makes all of these things correct. It's cleaner code to write. You'll see it's such short code you won't believe it. There is proper error handling, data, loading, and error feels like they're interconnected to each other. You'll know why. So now you might think, how do I get the value from this async value, right? Well, the answer to that is if you just use user now, user dot, you'll see you'll get many options like user.asData. So if you do as data, it will give you a value of the type async data user. But that's not what we want. We directly want to access the data or the loading or the error part, or three of them we want to handle together. And for that, we have the function .when. And when we do this when, you can see we have three required parameters: data, error, and loading. For data, we'll get a simple data. So whenever we get the data, what do we want to do? If there is an error, we'll get error and a stack trace both together. And what do we want to do then? And if it's loading, well, if it's loading, what do we get? Nothing really, because it's loading. We don't want any data. And now we just handle all of these states. You don't have to write the big future builder code anymore. You just have to write user.when. That is basically short for ref.watch.when. It's basically like this. So we are watching the future provider, and whenever we get any of these, so data, error, or loading, it will make this happen. And in case the loading shifts from data, it dynamically does for us, just like future builder, you know. So now we can handle the data. So in case there is a data, what do we want to do? Well, I just want to return a scaffold. Very simple. But what do we do in case of error? Well, in case of error, let's just simply display a error in the middle of the screen. So we have error.toString. And for loading, we are just going to return again a center widget with a child of circular progress indicator. And there we have it. With just simple line, we have solved the future builder big boilerplate code problem. And we have handled all of the states correctly as well. And here it's giving us an error because we have not returned anything. You'll say we have returned from data, error, and loading. That's right, but we have not returned this entire future builder thing. Sorry, it's not future builder, but replacement of future builder basically. So now you can have return over here and all of your problems fixed. Now if I just restart the app, you can see we are getting this loading bar and then we are getting the screen. Now to display the data, if you come over here, this is of the type user. So to display it correctly, all you need to do is data.name and remove the constant from here. Now restart the app and you see the name showing up, and that's the exact name that's over here. So we have successfully got the data. If you're wondering why on restarting the app we get this loading indicator, the reason for that is we have returned this entire scaffold in the data. but we have not returned the entire scaffold in case of a circular progress indicator or a centered text. So if you want to get a white screen, you can just wrap these widgets with a scaffold. Now I want to show you the process of error handling. So if by mistake I mistype it, so if I just do users, which is another API of its own. So if I just go to users over here, you'll notice it gives us a list of all the users. So if I do this and do this, it won't work because it's giving me a list of user. Earlier it gave me a map of all the user. So I could directly use user.fromJSON. But in case of all the users which are in a list, I have to do a for each loop, right? I've not done that. So it should likely give me an error. So I'll just restart the app, and here you can see we are getting this error. It's not properly visible because we have not wrapped it with scaffold. If you want, you can wrap it with scaffold to see it properly. After you do that, come over here and you'll see type list of dynamic is not a subtype of type map string dynamic. As I said, this thinks that this value.body is of the type map, but it's actually a list, and that's why we get this error. So we have the proper error handling done as well. There are a few more properties over here. So if you just do ref.watch fetch user provider dot and then you check, there are more properties, like if you want to check if it has error or not, if it has value or not, if it is loading, if it is refreshing, if it is reloading. Then there's when and whenever data. So if you don't want to handle all of these states like error and loading, you'll just do when data. So whenever you get the data, this whatever you pass over here will rebuild. So these were all the important functions. Another important function if you want is .map over here. So if you do .map, it's similar to .when. You'll get all these functions, but now the value will be of the type AsyncValue. So here, like we had the value of AsyncValue, here we have all of these values like AsyncValue. So if you just hover over this, you get not AsyncValue, async data, and then you'll get user. So if you want to access the user value in it, you can do data.value and it will give you access to the name to the user model, and then you can call .name.email properties on it. Now after having this FutureProvider, let's talk about this ProviderRef. I know I told you I would talk about it early on, but let's talk about it now. So generally, when you have this kind of HTTP requests, you won't be directly writing this in a FutureProvider. Instead, what you'll be doing is writing this in a separate class of its own. So you'll have something like class user repository or something. Let's just call it a user repository. And in here, you'll be using the HTTP call. So if you are here, you're just going to write this entire code in a function. So you're just going to have future user fetch user data, and then you're just going to have your calls right here, and obviously the HTTP part. And then you'll be using something like user repository dot fetch user data. And obviously you will have to return something from here, otherwise your FutureProvider will be of the type null. So after doing this, you might think that, yeah, the job is done, but generally all of these repository classes and all of the classes that you have are provided. So a provider is used for them. Why a provider? Because suppose you have a lot of things to be taken in from the constructor. So for example, you're testing your code. So if you're familiar with testing, you might know that all of the dependencies are taken in from the constructor, and then in the testing screen, you'll mock it. If you don't, then that's how it's done. And if it doesn't make sense, don't worry about it. But generally, dependencies like Firebase, if you're using, it's taken in from the constructor. If you're using HTTP, an HTTP client is taken from the constructor, and so on. Then a provider is created out of that. So you have user repository provider, which will be equal to provider ref, and then user repository classes return. Now, if there is a constructor, there will be multiple parameters to pass in, and you can pass it right here in the provider itself. The reason for that is I said they are going to be dependencies. You can pass dependencies from here. And if it doesn't make sense, like why would anyone do that? You can check out my testing video, which will be out soon. But that's how generally it's done. So if there are like 5 to 6 things taken in from the constructor and you want to use user repository, suppose in a 20 or 30 providers, that will be very difficult, right? Just using this class and instantiating it every single time is just a waste of time for us. So instead, a user repository provider is created or a provider is used for these classes. In our case, there is nothing like that because you're not testing, but it's generally done that way. Another reason to use provider can be because provider will cache it and return its instance pretty quickly. Otherwise, we'll have to keep creating the object of this user repository class again and again, which will be causing memory issues. Instead, if we just use this line, it will cache it for us because provider just caches stuff, whatever we pass it in, and will provide it to us, thus not increasing our memory space. So now what do we do? Well, I'm not going to use user repository class now. Instead, what I'm going to do is grab an instance of this user repository class. So I have user repository, suppose like this, which will be equal to ref.watch. Now you might get confused that ref.read should generally be used, right? Because this is not a build function and I said ref.watch should be used outside the build function. A ref.watch should be used only inside the build function, not outside. Outside is ref.read. And even in functions, it's ref.read. And this is a function, right? But those things aren't applied here. Of course, I'm not saying you can't use ref.read. You can use it. The reason for not using it over here and even in the build function is that if the value of this of this provider changes, for now it's a provider, so its value won't change. But what if it's a StateNotifier that we are dependent on? The syntax I'm showing you is accessible for all the type of providers. So you can access a provider, StateProvider, StateNotifierProvider, ChangeNotifierProvider, and if you want a FutureProvider itself, and of course the syntax that I showed you earlier of using ref.watch if you don't want an AsyncValue, .when and whatever. But that's how we do it. If you do read, it will just take in a one-time value and then think, yeah, this is it, and it will not continuously listen. So if the StateProvider, StateNotifierProvider value changes, it will be bad because we won't get the updated FutureProvider. If we use ref.watch instead, if the value changes, this FutureProvider will rerun and notify all of our clients, for example, this home screen, and tell them, yeah, the value has changed, so please help me out right here. Just rebuild my widget tree and it will rebuild. So I hope that was clear. Now I just want to use ref.watch user repository provider, and that is why this ProviderRef helped us. This ProviderRef allowed us to talk from a provider to another provider. WidgetRef allowed us to talk from widget to a provider. And now, of course, you have access to the user repository class, so you can just call return user repository.fetch user data, and you're done. If you just restart your app, you can see the name shows up correctly and all is well. So I'm going to keep the FutureProvider here just as a reference to StreamProvider and other properties that are available, which I want to show you after we complete the sixth and the final type of provider in Flutter Riverpod package, which is the StreamProvider. So let me type it right here. To create it, we already know we're just going to have final some stream. So you can name whatever you want. I can't think of any name. So I'm just going to have StreamProvider ref, and then we have it like this. Now, obviously we need to return a stream, but since I don't have any stream APIs in my mind currently, what I'm going to do is use async star, which will allow me to return whatever values that I'm returning from here as a stream. And to do that, I'm going to use the yield keyword. And after that, I can return any value. But since this is a stream, I think it makes much more sense to use changing values. So I'm just going to do this. Of course, if you're not me, you can use a for loop instead of typing all of these tasks. But anyway, after having this done, you have a StreamProvider ready. If you have some Firebase calls, like you can do something like Firebase Firestore.collection, and then the name of the collection suppose is users.document user ID dot snapshots, and that will give you access to Stream, and then you can return it right here. But since I don't have Firebase Firestore plugin, anything done, I'm not using that. But I've already covered it in some of my builds. You can check them out. Link will be mentioned in the description. So anyways, we have it right here, which is good. The thing to note is, after adding async star, you can yield and it will give you all the possible values. Like you can return the possible values, which will keep changing and it will keep returning it. So after having this, I'm just going to go to the home screen, and now I'm just going to comment all of these lines. I'm commenting it and not deleting because I want to give some major features on FutureProvider and StreamProvider that are left. Alright, so now you can do return. Of course, the syntax for StreamProvider is very similar or exactly the same like FutureProvider. So all you need to do is ref.watch. After doing this, type the name. So mine is StreamProvider. Dot. When this also is the type of, gives the type of async value. And now you get the data, you can handle that. Error, you can handle that. And it will also give you stack trace and loading. So you can handle that as well. Loading and all of those tasks are pretty similar. So I'm just going to copy paste them. So after having all of this, the last thing that I need is data. And what am I going to do? Well, you can see it's a list of int that I'm returning. So you can either use list view builder or whatever. I can just use return text data.toString so that it displays a text with the list correctly. So I'm just going to restart, and here you can see I get all of this. The reason for that, again, I'm not put in a scaffold. You always want to do that. And in case you're wondering, if I have to do it for all of these scaffolds, why shouldn't I just put it outside? And you're absolutely right, you can do it. So you can just do return scaffold. Alright, and then in the body you can have all of this task done. So now you don't need to add any scaffold over here because your parent widget is now a scaffold. So it's not required here as well. And now for the loading part, you'll also see there's no black screen coming. I'll just restart and there's no delay, but you can see our list is right here. I hope you can see it. So this was it about the stream builder. If you have any stream values which is going to change, you can keep doing it. So if you have 11 and 12, restart it and you'll see 11, 12 right here. Great. So this was about stream builder. Again, it has the same properties like future builder, like has data, has error, is loading, and all of that stuff. I'm not going to dive into it again. You can check them out for yourself. There's map method, when data, when or null, whatever. So after getting all of that done, what are the key features that I wanted to note? Before noting them, I want to say that this ref is available on every provider, right? So you can communicate with all the providers that you want. So if you again want to do this user repository task and return it, you're good to go. Now, what are the features that are available to us? And it's not just for FutureProvider or StreamProvider. It's available on every single provider. Keep it in mind. It's available on every single provider, but it's generally used more with FutureProvider, StreamProvider, and StateProvider, StateNotifierProvider, all of them, not with a single provider. What am I talking about? Well, it's the modifiers. Modifiers mean if you just come to this FutureProvider, I told you can add generics, but other thing that you can add over here is .family. With family, what happens is, suppose I have this FutureProvider, but I want to modify this function a little bit. I want to get this user value based on the user input. So I'm just going to have int input, and I can take this, pass it in and do the string interpolation. This is not a string anymore. This is variable URL. Alright, now I have the user input. So whatever the user types, we want to get that user's data. So if I have this API and I do user/5, it will get me a different person. So I want to do exactly that. Now, how am I going to do that? Well, you can see it here, it asks for the missing argument. If I type in 1, it gets satisfied, but this is still not the user input. User input is what is entered on a different screen altogether. It's right here. So I'm just going to comment this StreamProvider for now. We have this provider now. And we are going to have, suppose, a text field over here, which will tell us what user value we want to get. In the UI file now, you'll have the user input, but for that you'll have to declare something that we will show to the user initially, right? And for that we are going to create an int variable, but doing it in a consumer widget, which is basically an upgrade over stateless widget, is not quite possible. I want to use set state now, so I'm just going to use StatefulConsumer. So I'm just going to use the StatefulConsumer widget, and I'm going to have my home page. I'm going to return everything from here. I'll return this class now, and now changing it to a StatefulConsumerWidget is now giving me access to create a page. Suppose the user number variable, which is initially 1 because I want to get the first user's data, but in case the user decides to just change the value which we want to get of the user, we'll have on submitted value, and then I can just do set state user number is equal to whatever value the user gives, and obviously parse it. So we have int.parse. Actually, we don't have to parse it because this is going to be of the type string, not integer, because we can't pass in an integer in a string, right? I mean, at the end of the day, it's just going to get converted to a string. But anyways, this is fine. This will also be a string, and this will be like this. Alright. So now after doing this, set state, usually set state is not used when Riverpod is used, but I'm just giving a demonstration because I just don't want to dive right into the clean code part. I'm just explaining it. So what happens is whenever the user gives a new value, I want this build function to rerun. And whenever this build function reruns, I want to give the particular provider the value. So I want to give the user number variable to this provider because here I want the same thing. I want to get access to what the user has typed, and that's why we use the modifier.family. When we use family in the parameter here, we can have a value taken in. So we have string, and that can be the input, and then you can pass that input right here. So this, as I said, is like a function, correct? So in the function I have another input, and getting that I have access to this over here. Now this throws an error in the home screen. To resolve it, what you need to do is you have this fetch user provider. You just need to add a function like this and pass in the user number. Simple. So we have done ref.watch the user provider, then you've treated it as a function, and in the function you've passed in the user number. If you remove this family, you don't have to pass that in, right? Now let's see it in action. So if the user, initially it's 1, so it's showing us this name, but if we do 5 and enter, you can see this entire rebuild, and we have Chelsea Dittrich, sorry if I pronounce it wrong, showing up. If I do 10, this shows up. Of course, this is not ideal. That's why set state is not generally used. You can use some other value, but I just wanted to point that out, that you can do this. Another thing that I want to point out is this family has a limitation right here. You can't have 2 inputs like this. So if you want to have int a, you cannot have 2 of them. You can only have a single thing taken in from the argument over here, or you can just pass in a single thing from here. You can't pass in two things. So that's one limitation, and we're going to see a solution for that, but that will include using a new package. If you don't want to use that in your application, you can obviously use some other types. So for example, if you want, you can use a package known as tuple. You can use that and you can provide values. It will give you tuple 2, tuple 3, tuple 4, all of that. So you can convert that into a single data type and pass it to this parameter, which will allow you to send in 4 or 5 values together encapsulated in one single data type. Another one of them is using a class. So you can just directly use a class and pass it in. But make sure that if you pass in a class, the class should be immutable. Meaning the class that we have right here is allowed. But you can't have a class that's immutable, meaning you can change the state of the class. We can't do that in our example because it's immutable. And you can pass in primitive data types, but you can't pass in a non-primitive data type from here. If you want to pass that in, you'll have to override their hash code, which is this, or the is equal to operator. Only then can you pass it in. But there is a problem with this line now. The thing we are doing is taking an input from this home screen, from this text field to be very particular, and passing it in over here. Now there are times that this input doesn't change, but there are times when the input can be changed, but it's never reused. So in that case, we have something known as autoDispose, which is another modifier we have access to. And you can use both of them together, or you can just use autoDispose if you don't want a parameter that your function depends on. So you can just use this like this, or you can just use family and autoDispose together. So when you do that, it will avoid memory leaks in your application, and it will autoDispose your provider with no memory leak, and it will, well, of course, dispose of your provider. It will destroy your provider's data and state whenever it's not in use. That's why so automatically it will dispose it off. And you can do the same thing for every provider. So if you have provider, StateProvider, StateNotifier and StateNotifierProvider, ChangeNotifier FutureProvider and StreamProvider. I also mentioned StateNotifier here, but there's no autoDispose for StateNotifier obviously, but StateNotifier provides us with one thing that I forgot to show it to you. So which is, if you extend StateNotifier, of course, you have to do user repository. I hope this is refreshing to your memory. And then you'll have super, and then you can do state, right? And this state can be a boolean value, for example. I'll just consider it that this boolean value is loading, just for now. And now you can have one method in the StateNotifier called dispose. Whenever you extend a StateNotifier, you get access to dispose, and you can dispose of whatever you need. So if you have a stream running in this user repository class, you can just cancel the stream subscription. So you can just call whatever stream there's .cancel, or otherwise if you have text input field, which is generally not used in repository but in controllers. So if you have access to text field repository and stuff like that, like final text field text controller, which is equal to text editing controller, you can just use controller.dispose and you can dispose it off. That's what this dispose is used for. But anyways, coming back to the original part and coming over here, it will auto dispose it off, and it's generally recommended to do for all of these providers. Unless there is a real use case for that. If you don't want to dispose it off, you want to keep the values constant, you can do that. So the same applies for StreamProvider. If you want, you can have family, you can have auto dispose, or both together. And the same applies for our provider right here. So you can have provider.family or provider.autodispose. We'll just use autodispose. Now if I restart my app, here we have it. Seems good. it will auto dispose it off whenever it's not in use. So if we change the screen, it will dispose it off. So now we are done with all the type of providers. We have had 6 providers to look at. To give you a refresh of that, provider is a read-only object. So if you want to provide a value, be it primitive data types like integer, boolean, string, you can use them, or non-primitive data type like list, map, whatever, or even instances of classes. I've already mentioned the reason why. Second is StateProvider. It is like an upgrade of the normal provider. If you just want to update a simple state like an integer value or a boolean value, you can do that. And just to get your minds more open to this, instead of using this user number, what you could have done is just used a very simple StateProvider, because all we want is a single string, right? So instead of using family, what we could have done is use a StateProvider, got the value over here, and updated it whenever the user submitted the text field. But since I wanted to show you the family feature, we could have done that. But if you want, go ahead and try it on your own. It should be fun for you. Second is the third one is StateNotifierProvider. This is generally used when there are more complex state to be dealt with. For example, the user class, and we want to modify their properties or whatever. Fourth one is ChangeNotifier It's recommended not to use by Riverpod. It's just for transition from provider to Riverpod. If you have bigger code base, this will help you. But if you're starting from scratch or you have a smaller project, I would recommend you to not use it because of its mutable state. Fifth one is the FutureProvider. So if you have asynchronous code and you want to avoid the wrath of this future builder and async snapshot, you can use FutureProvider. Sixth one and the final one is StreamProvider. So if you have a stream and of course you want to get rid of the stream builder and async snapshot again, you can use StreamProvider. It is reusable and it should help you a lot. Alright, now after knowing all of the providers, there are some methods on ref that I want to talk about. So we saw the different types of refs. The first one is the WidgetRef. Helps us to talk from a provider, from a widget to a provider. Second one is the ProviderRef, which allows us to talk from a provider to another provider. And the third one, which we have not talked about, is a simple ref. So what is this ref? Well, ref can be considered like a super class to this ProviderRef and WidgetRef. For example, if you have this user repository class and your user repository class needs access to ref, generally, as I said, repository classes don't contain such logic. It's just for business logic. But however, if you by chance need it or any of your classes need that, you'll have ref used here. This ref will allow you to talk with other providers. So if you have ref.watch, similar methods, it's like not even similar, it's the same method. So you can use ref over here and then you can communicate with all the providers that you need. So for example, if you need a stream value, you can use fetch user provider, because these providers provide value to not just widgets. It can provide a value to any classes, any functions, anything that you want. So you can have user repository here and then just have this .ref. And now you have to pass it in. So what do you pass it in? Well, just a simple ref. So you can just pass in a ref over here, which we got from this parameter. You can just pass it in. And this allows you to have ref.watch, ref.read, and all the ref methods that we have access to. Now, after knowing this much, we can come back here. There are other ref methods as well. So the first method that we are going to talk about is ref.keepAlive. So we have ref.keepAlive. After using this, basically, whenever we use autoDispose, this method gets activated. However, if you don't have this method, so I'll just remove this, you can see .keepAlive method is no more on it, because that's what its use case is. Whenever you dispose of, so when you transition from one screen to another, or the future provider is just not in use, and you want to preserve the state of this future provider, you can use ref.keepAlive. So that will make sure that the state of this provider is there even after it is disposed, right? Second one is onDispose. So whenever dispose is called, what do we want to do? And this onDispose method is available even if autoDispose is not there. So it's available, and if you have it, then also it doesn't matter. So whenever your provider is disposed, what do you want to do? So in case of dispose, you want to make sure that, suppose you have the HTTP client example for here, you can just do http.client.dispose, or if you have text editing controller, you can dispose it off, or whatever needs to dispose of. So if you are in a StreamProvider, you can use that over here as well. So I'm just doing it for both of them. And whatever methods I'm telling you is available on all the providers that we're talking about, okay? I'm just giving you an example of showing it on one provider. So whenever onDispose is called, you can just do, well, whatever you want to do. So if you have a stream subscription going on here, you can cancel it. It will get cancelled by autoDispose, I guess. But if you want to dispose something else, you can use that. Then you have access to onCancel. So you have ref.onCancel. OnCancel is used whenever your provider goes into a paused state. That means it's no longer being used for a certain while, or it gets disposed. That means it's no longer being used anytime. So that time that onCancel gets run. So it's for both the cases, temporarily pausing and all time pausing, or forever pausing, whatever way you prefer. And then there's ref.onResume. So whenever your providers get resumed, what you want to do, you can just type, you can just pass it over here in this function right here. That means your provider was in a paused state and it starts to rerun again. So after it was going into the cancel state, and when it comes back to the onResume state. So these are kind of like life cycles of this ref, which you can get access to and do your work. But generally, I don't think for a smaller app you'll ever need this. And the final function is onRemoveListener or the onAddListener. So whenever a listener is added to the StreamProvider or the FutureProvider, you'll use this. So these are the very important methods. The last thing that I want to talk about in this Flutter Riverpod package is something known as a ProviderObserver. Now I told you if there are global variables, it would be very difficult to understand where the provider is being added, where it's being removed, where it's being listened. So it is quite a task. But with access to this something known as a ProviderObserver, you can log these things out. So I'm just going to go in the lib folder, create something like a logger riverpod.dart file. Then I'm going to call this logger riverpod, and then we need to extend to something known as a ProviderObserver. So after we do this, we will get access to something known as an override method, which is called void_did_update_provider, and it gives us access to all of these things. So there is provider base, which is like a base class for all the providers. So if you just go to this FutureProvider, you can see it extends the FutureProvider base, and FutureProvider base extends the provider base. So this is like the parent class for all the providers. Then there's the previous value. So what was the previous value of our provider? Then what is the new value of the provider? And then the provider container. Provider container is what is used within the provider scope. Provider scope is made of this provider container. You can see it, provider container, and it's used at a lower level. And now if you want, you can print all of these things out. So you can print all of these values. Now just restart your app, open up your terminal, and to make this logger work, what we need to do is go to this provider scope, and in here we have a bunch of more properties than just a child. So we have overrides, observers, and parent. You might know where to put it in the observer because it accepts a type of ProviderObserver. So we can just have observers, pass in our logger Riverpod, and this is not a constant anymore, so let's remove it, and constant is just my app. Now if I restart the app, you can see when the FutureProvider came up, we have autoDispose FutureProvider, which is the provider base. Then we have the previous value, which was the loading value, right? So whenever we launch our FutureProvider, first there is loading because it's fetching the data, and then when it gets its value, it gets async data user value, and the user value is written right here, and we have a container instance of provider container. Now if I just change it, so if I write 10, you can see it again ran, it gives us this value. It's pretty good to debug with this if you want to know where or what provider changed and how it changed, all of those things. There are more overrides like this. So the next override is @override void did add provider. So this is done whenever the provider is initialized. It just requires provider, the value, the initial value, and the provider container. And similarly, we have for @override void did dispose provider. So whenever obviously a provider is disposed, you'll get values where we won't even get access to value because it's getting disposed. What's the purpose of getting the value? We just get the provider base, which provider is getting done, and the container. You can obviously add print for all of them, but these are the 3 overrides that you can have after you extend a ProviderObserver and let ProviderScope know that we are observing all of this. If you want to go ahead and try it out, print it out and see the output for yourself. It's pretty amazing. It will help you in bigger application. There are multiple more functions that are very useful while testing. So you have ProviderScope, and there you have the overrides property. So if you want to override a certain provider with a certain value, for example StreamProvider, you can do override with value and provide a new value to it. So you have pass in the new value in the form of the stream. So if you want a stream of list of all of this, you need to pass it in, and you can override it, and it will help you in testing. If you're familiar with testing, you might know why. If you're not, don't worry about it. This might also help you. So this was it for the entire Flutter Riverpod package. I've explained to you all about providers, the WidgetRefs, but that's not all it. We have not done with the tutorial yet. There is a main thing left. After having the knowledge of Riverpod, let's discuss some of the disadvantages of Riverpod. First, you might notice that there are so many providers. There are 6 providers for us to choose from. It can be confusing and difficult to choose which one to use. Second disadvantage is that over here in our home screen, we are using ConsumerStatefulWidget instead of StatefulWidget. And in StatelessWidget, we are using ConsumerWidget. Using this is quite a task because converting it into a StatefulWidget and then converting it to a ConsumerStatefulWidget, that is a bit of a task. Third disadvantage is in our providers, when we use family, I told you we cannot have more than one type of parameter. What if I want to get input of 3 or 4? I told you can use tuple or anything like that, but do you think it would be more convenient if we had access to a way which would allow us to add more and more parameters? And also, if there were more parameters, we could use named parameters. So instead of having positional parameter, we could have named parameters just like we have for functions and classes. So these are the basic disadvantages of Riverpod. Now, what are the solutions to it? Well, there are solutions to a few of them. For so many providers, we have a package that we are going to look at, which is called Riverpod Generator along with Riverpod Annotation. We're going to dive deep into it, but for a basic level, that's what we are going to use. Converting to a stateless or a stateful widget over here, we have an extension in VS Code called Riverpod Snippets. You can install that, and after you install that, you get access to something like this. So if you just type stateful, and it will give you access to stateful consumer. So now you can just create home screen like this, and all the boilerplate code is generated. If you want a stateless widget, which is consumer stateless widget. So you'll just have stateless consumer and you get access to it. If you want to create a provider, you can just type provider and all of those is done. So I can just type simple provider, give it a type. If you don't want to give it a type, remove it. And then we need to return a simple value. And the same goes for all the type of provider, be it FutureProvider, StreamProvider, or StateProvider, or even StateNotifier and StateNotifierProvider. So this is a handy snippet for us. The third is the family part. So having more than one parameter, well, there is the cool part. The package that we are going to use, Riverpod Generator and Riverpod Annotation, will allow us to add multiple inputs, multiple parameters for our family. So we're going to take a deep look into it and let's get started now. To get started, go to your pubspec.yaml file and add Riverpod Annotation package in dependencies, and in the dev dependencies add build runner package. This build runner will give access to code generators and Riverpod generator package, which will allow us to generate Riverpod files and classes. This Riverpod annotation will give us access to @Riverpod, which we will see right now. So now if we come over here, let's try to replace this FutureProvider by writing with the Riverpod annotation package. So what are we going to do? Well, we have first of all @Riverpod. Alright. Now after having this, we will click on enter. You can see we have imported Riverpod annotation package. After that, we need to write our simple function. Just like we write a very simple function, but it should be globally present, just like our providers. So here we will have future, because that's the return data type of this fetch user data function, future user. So we are just going to have that. And we are going to call this fetch user. You don't have to write provider after this, because you'll see later on that the name of a provider is going to be fetch user provider. We just need to write fetch user and then create the function. Now in the function, obviously we are going to have these two lines passed in, because that's what we want to do, and we'll comment this out. We don't need this provider. Now in this parameter here, we will have access to something known as fetch user ref. Now this won't make sense, but when we do something, you'll understand why we are doing it and what we are doing. And then we want the string input. So we are basically getting access to ref just like we did over here, and the input just like we did over here. And you can see we are getting this error, but we shouldn't worry about that. Now what we want to do is add a line over here called part, and in this part we need to write main.g. So basically you'll write the name of the file, and in between you'll add .g. Now I know this is not making much sense to you, but so now what you need to do is run build runner and then add watch. So after doing this, you're continuously watching for any changes in the file. And you can see after it succeeds, all of our errors disappear. So how is this suddenly happening? And how do we have access to something known as fetch user ref? The answer to that will be found in main.g.dart file, which is automatically generated. These are what are called code generators. After running this build runner, this file automatically generated, and it says do not modify by hand, and it's a part of main.dart file. So we don't have to import main.g.dart file anywhere. We just have to import this file just like we do for our providers, but it will automatically get the stuff that is passed in this file. And what do we have in this file? Well, you can see fetch user provider class, which extends autoDispose FutureProvider. So it automatically got to know that, yeah, this is of the type future. I want to give it a fetch user provider, which is of the return data type future user provider. You can see it. And we also have access to fetch user ref, which is autoDispose FutureProviderRef. So basically what it has done is created this line, and we just had to write a simple intuitive function, and that's how useful these functions are. All you need to do is add the Riverpod annotation, create a function, and you get it. Now in the home screen also, you can see nothing changed because as I said, we all only need to write fetch user and it will create a provider based on fetch user provider. So I hope that was very clear. Now let's try to do the same thing. Of course, if you want, you can compare the syntax. This is much more intuitive because it's a function. Now let's go to the user.dart file and we have our user repository provider. Let's try to write a code for the same. So we are going to have, well, user repository return. Then we are going to name it. So we are going to name it user repository and then give something known as user repository ref, and then we want nothing else. So we'll just have this done. Then we are going to return the user repository and pass in ref. Alright. Now what we need to do is go up at the top and add part user.g.dart. Make sure to add this, otherwise it won't work for you. And the reason it's not getting auto-generated, as I said, if you don't add @Riverpod annotation, it won't work. So just add @Riverpod and then save it. And as you can see, it took a bit of time and it generated user.g.dart file. And it just works. You can see when we do user repository, we watch user repository provider, it all works. Now the last thing that I want to show you is the family tag. So for the family, I told you we can't have more than one input, but here you can see this is a simple function, right? So we can have more than 2, 3, 4, parameters, as many as we want. So here I'm just going to take an int some value, then boolean second value, just for seeing that what we get in the reference. So now after I do this, the main.g.dart also updates, and when you go over there, you can see fetch user provider now has some value and second value. So when you go to the home screen, you can see we need to add 3 additional arguments now. So we need to pass 1 and false over here. Only then will our code run. However, when we have more than 2 or 3 kind of parameters, we generally use named parameters. So now we can just wrap them like this and have required, and if you want you can make this nullable, but I also want this required. So after you do this fetch user ref should always be non-required, so that means it is a positional argument, but all of this are named arguments now. Now you can come over here and here you need to pass in the named parameters that are required. So this should be input, then this should be some value, and this should be second value. After you do that, you can see all of the errors disappear and we get nice little multiple family things, and it's much more cleaner, isn't it? Because having more than 2 inputs always requires us to not get confused and add the named parameters. So this was it about Riverpod Generator, but I can't show you more example because the only 2 types of provider that are supported till now are FutureProvider and the normal provider. StateProvider, StateNotifierProvider, ChangeNotifier and StreamProvider are not yet supported. However, for StateProvider and StateNotifierProvider, there are some replacements, but I'm not going to look at them in this tutorial. If you want to know more about them, let me know in the comment section and I'll create a separate video on them. But there are many benefits that you saw and it solves most of our problems, and soon I think most of these providers are going to get supported. Also, another thing that I forgot to point out is that if you go in any of this, you'll see autoDispose FutureProvider. So it automatically adds the .autoDispose for us, and that's very convenient because many of the times even I forget to add it to my providers. So it's a really cool feature. Of course, if you want to keep the state alive, you can use ref.keepAlive and all of that stuff, and you can use both of them. And whenever you use Riverpod annotation or Riverpod generator, it's not necessary that you always use this @Riverpod and create a function out of this. You can also create a normal provider and it would just work fine for you. As you saw, this is much more intuitive. This was it for the tutorial. If you're interested in building projects with Riverpod 2.0, check out these projects on the screen. Thank you so much for watching, and I'll see you in the next video.